Trigonometry, Chapter 5, Trigonometric Identities, Section 4, More Identities, Video 13, using half-angle identities, Part 3. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we used half-angle identities to evaluate trig functions. Just a reminder, when there's a plus minus, the choice is made based on the trig function of the half angle and the quadrant of the half angle. In this video, we use half angle identities to simplify expressions. For example, simplify the expression, the square root of 1 plus cosine 6x over 2. Well, first we have to find an identity, half of which resembles the structure of this expression. Can you find one? I can. Notice this expression has the same structure as cosine of x over 2 equals plus minus the square root of 1 plus cosine x over 2. It's missing the plus minus, but that's okay. We can still use this. Replace each x with 6x because that's the argument of the cosine in our expression. So in the identity, we're going to remove the x's and we're going to replace them with 6x. 6x here, 6x here, and we have cosine of 6x over 2 is equal to plus or minus the square root of 1 plus cosine 6x over 2. Of course, on the left, 6x over 2 will simplify. This will reduce to just 3x. And as a consequence, we have our answer. The square root of 1 plus cosine 6x over 2 is equal to cosine of 3x. And again, it is worth mentioning that technically the plus minus would need to be there because we don't know the quadrant of 3x, but on the assumption that it's not an issue, this is a perfectly viable and acceptable solution. Let's try this one. Simplify the expression. Sine of 5 alpha over 1 minus cosine of 5 alpha. See if you can find a half-angle identity whose structure resembles this. I guess I should say pause the video, but I usually say that towards the end. Did you find one? Maybe, maybe not. The expression almost has the same structure as the tangent half-angle identity. Specifically, tangent of x over 2 equals sine of x over 1 plus cosine of x. But it's not the same structure. You see the difference, right? It's not the x and the 5 alpha. That's interchangeable. It's the signs, the minus versus the plus. We cannot conveniently change the addition in our identity to the subtraction in our expression. And if you're thinking, what if we try some algebra shenanigans, multiply both sides of the fraction in the identity by -1, or multiply both sides by a conjugate? You can try those and you'll see that they will fail. So we have the wrong identity because of the minus sign versus the plus sign. So instead, let's compare to the tangent half-angle identity that does have subtraction. Namely, tangent of x over 2 equals 1 minus cosine x over sine of x. And now you're probably thinking, okay, so we fixed the negative, the minus, but now the fraction is completely upside down, so it doesn't have the same structure. It's upside down. It's upside down. It's the reciprocal. We can capitalize on that. Notice if we reciprocate this half-angle identity, it would have the same structure as our current expression. In other words, if I reciprocate the right side, I'll have the sine on top and the 1 minus cosine on bottom, which is exactly what I need. But what do we get when we reciprocate the left side, when we reciprocate tangent of x over 2? Now, if you're thinking of tangent of 2 over x, no. Because when you reciprocate a trig function, you don't reciprocate its argument. We need to reciprocate tangent, not x over 2. And the reciprocal of tangent, of course, is cotangent. So if we take the reciprocal of both sides, we get a new version of this identity. Cotangent of x over 2 equals sine of x over 1 minus cosine of x. And now we just replace the x with the 5 alphas, and we're through. So Sine of 5 alpha over 1 minus cosine of 5 alpha equals cotangent of 5 alpha over 2. Now you try. Pause the video and see if you can simplify the following expressions. We have the square root of 2 over 1 minus cosine 40 degrees. Wish that were reciprocated. And we have the square root of 1 minus cosine 80 degrees over 1 plus cosine 80 degrees. All right, if you haven't paused the video, here's your warning. Solutions in 3, 2, and 1. As mentioned on the first one, it does have a reciprocal nature. So I wrote it as 1 over the square root of the reciprocal, which is the sine half angle identity, which gives us 1 over sine of 20 degrees, which is cosecant of 20 degrees. And the other one is just a straightforward tangent of 80 degrees over 2, which is tangent of 40 degrees.